Hello everyone, welcome back. Sorry about that, my video cut out on me. So where was I? So we're talking about how to predict whether or not a redox reaction is going to be spontaneous the way it's written, or if it's going to be spontaneous in the opposite direction. So we're going over part B. So this is our redox reaction for a electrochemical cell. And we're figuring out, is this going to be spontaneous as it is written? So again, you have to write the two half reactions, the reduction half reaction and the oxidation half reaction. And you got to look at the standard electrode potentials for those substances, right? So here, the electrode potential for iron is negative 0.45. The electrode potential here for lead is going to be negative 0.13. So this has a more negative electrode potential. That means it's going to repel the electrons more than it is going to be for this one. So repelling the electrons is not favorable for reduction when you're supposed to gain the electrons. So for this one, you're more likely to undergo oxidation, which is what we have written here. And this one is going to undergo reduction. This is more likely to undergo reduction, so which is what we have here. So this electrode is going to experience oxidation, and this is going to experience reduction. So that is exactly the way we have it written for our equation here. So the way it's written is indeed spontaneous. So the way we should write our sketch, our electrochemical sketch, is we need to change a couple of things. Now this time we had the electrons going this way towards the iron, but now it's going to work in the opposite direction. So the solid iron, is going to lose the electrons, and the lead 2 plus is going to pick up those electrons. So all we need to do is change our picture a little bit here. Notice that I have anode on this side. So the anode is where oxidation takes place. But oxidation is now going to take place here. So we're going to lose electrons going in this direction. So the electrons are going to be moving in this direction. So iron is going to lose the electrons. That means that this is now the anode, right? So I just need to change that. And this is now the cathode, where reduction takes place. Cathode. Okay, so with regard to the elements now, so here that stays the same. That's going to be iron. But now we have lead here, so this is going to be a lead electrode. So this is going to be Pb, lead. And so instead of magnesium losing electrons becoming Mg plus, we're now going to have in here not a magnesium solution, but a lead 2 plus solution, right? And here we're going to have lead. And so the electrons are going to come here. The lead 2 plus is going to gain those electrons. And your lead 2 plus is going to become lead. And this electrode, the iron, is going to lose the electrons. So now the arrow here is going to go in the opposite direction. So here, iron is going to become iron 2 plus. And so now it's going to be, what the case is, the spontaneous direction is this way. This electrode is going to grow because Pb2 plus is becoming Pb. So you're going to have more lead collecting on this electrode, so it's going to grow. This electrode is losing iron and becoming iron 2 plus, so this one's going to corrode and get smaller. And then, of course, you've got, again, your salt bridge. And in this case, this, as more 2 plus ions become neutral lead, this is going to become less and less positive, and this is going to become more and more positive. And so if this becomes more positive here, then again, remember, electrons are more attracted to the positive side. So in order to keep the electron flow going this way more for a longer period of time and more strongly, then you have these ions in your salt bridge that are going to be able to flow to counterbalance the less positive here. So this becomes less positive or more negative. Then the positive electrons will flow this way to kind of balance that out, and the negative electrons will flow this way to balance it out here. Okay, so that is how you would sketch your electrochemical cells. That's how you predict whether or not the reaction as written is going to be spontaneous, or if it's going to be spontaneous the opposite direction. I hope this was helpful. If you like my videos, please like, share, subscribe, hit the notification bell, and put a comment in the comment section. Thanks for joining me, and I'll see you next time.